Alright, I'm going to try to fly through this flowchart really quickly. I want to point out a couple things. If you click on this, it'll take you to a YouTube channel, and it covers the basics of everything that we covered. Over here, I suggest you watch the CTQ explanation. This will be on the test, so this is kind of just a breakdown and review of what we covered. Over here, just density calculations. You guys did that. Over here is salinity calculations. Alright, so just going through really quickly, there are three main gases in water. Cellular respiration, not breathing, that one's oxygen. Carbon dioxide for photosynthesis, nitrogen, the most abundant gas. This one I changed from the earlier periods, but just to clarify, four main solids in water are NaCl. Over here, and this you can find this on Quizlet, so it's not in the notebook, it's in Quizlet. Also calcium, you don't have to put the plus right now, but just know Ca and CO3. You don't have to put the CO3 minus. Alright, moving on over here, salinity is how many grams of salt are in water, breaking off to number 7. It's at 0/00 or ppt. It's basically how many grams of salt are in every 1,000 mLs of water. Know that as salinity increases, density increases. The opposite is true. As salinity decreases, density decreases. Layers of the ocean, there are 3 of them. This is straight from your notebook, so I'm going to skip that. Moving on to number 15. Be able to explain why the ocean is salty from the water cycle diagram. I'll accept 2 answers here. One is the one where water goes into the ocean. It takes a little bit of salt. The water evaporates, and it doesn't take the salt with it. So it just keeps doing that over millions of years, and the ocean gradually gets saltier. And also the new one, which is we get most of the salt from hydrothermal vents. So I'll accept either answer on that one. Over here, density is a measure of mass per unit volume. So if you put like G per ml, that's probably okay, or gram per cm cubed, that's fine. But really it should be mass per unit volume. Unit for density, just make sure you know ml, cm cubed. Unit for volume, density is grams per ml or grams per centimeter cubed. Unit for volume is ml or cm cubed. Unit for mass is always gram. Know that things that have a density above 1 will sink in water. Densities less than 1 will sink in water. Alright, over here, a lot of this stuff is found on Quizlet. I'm going to go through a couple of these really quickly for you. So 97% of the dissolved material inside of the ocean is sodium chloride. The other stuff is like calcium and carbonate. Over here, this does not equal 100%, but again, out of all this, about 55% of it is chloride, about 30% of it is sodium. Coming over here, 97% of all water is inside of the ocean. 47, we're going to go ahead and say that there are 3 main components of the water cycle. This kind of relates back to one of the questions up above. When water evaporates, the salt stays behind. 45 and 46, I'd like you to go on Quizlet, take a look, and find out what they are. Alright, 22, a hypothesis is written in the if-then format. These 2 I would like you to look inside of the notebook to find out which one is dependent and independent variable. Over here, make sure you know that when both variables move in the same direction, both move up, both move down, it's called a direct relationship. Over here, one goes up, one goes down, then we call that an indirect relationship. Alright, coming over here to number 27. So water has, so the bonds we talked about, I'll accept 2 answers here. You could put 2, or you could put 3. Inside of the notebook, we had 3 columns like 1A, 1B, 2. So that's where the 3 comes from, or, you know, you can lump like 1A and 1B as 1, and then the next one as 2. What's important is you know the difference between the bonds. So this one here is a totally different one. This is an ionic bond, which is when one electron is taken away from another. This creates 2 very charged particles. An example of this is sodium and chloride, Na+, Cl-. Sodium chloride, also known as salt. Alright, over here, when a bond, so this one is a covalent bond when bonds are shared equally. So this one, again, make sure you know this one. So for sure, right here. Now when electrons are shared, but they're shared unequally, we call that a polar covalent bond. So this one is a polar covalent bond. The polar covalent bond will lead to the hydrogen bond. So this gives oxygen a slight negative charge, a hydrogen a slight positive charge. Look at the diagrams inside of your notebook. Water's ability to stick to itself, this is called cohesion. There is a difference in charges right here. This will create the hydrogen bond. So all these 3 things are kind of related to each other. As salt is added to water, its ability to stick to itself decreases. This means you see a decrease in cohesion. This means that there are less hydrogen bonds, so 37 and 35 should be the same answer. Over here, water's ability to stick to other things is called adhesion. Water's ability to store heat, heat capacity, and then I'll let you look up this inside the notebook. It's one of the last things that we wrote. Alright, then I want to come over here to the notes. Not that this is just stuff that people tend to have problems with, so I want you to look at it so you don't have problems for tomorrow. Make sure you know what water is made out of. Most people are okay with that. Physical properties of water, make sure you draw that. States drawings, again, make sure you know that there are 3 physical states of water. Over here, make sure you know adhesion, cohesion. This grid you're going to have to know really well. Know which one has the solid lines, which one has the dashed lines. So right here, again, you guys are going to see, again, solid lines. When you guys get to hydrogen bonding, you're going to see the dashed lines. Over here, dissolving ability. This is the one where you create 2 very charged particles, the sodium and the chloride. This is due to the ionic bond. If you remember back to this little video that we watched, make sure that if I gave you something like this to label, you would be able to label it, or you would be able to recognize if I messed with the diagram. Like if I put something in the wrong spot, you'd be able to tell me what's wrong with it. Make sure you're good with all this, your scientific variables, what you measure, what you change, what you control. Just a little bit on heat capacity, why do we have it, components of water. So this one right here is primarily sodium chloride. This is the one on Quizlet, so sodium and chloride. And this one is calcium. This one is CO3. You can put the CO3 minus if you want. Down over here were gases. You have nitrogen, oxygen, carbon dioxide. Density, make sure you know how to calculate for density. I'm going to ask you to solve for mass. I'm going to ask you to solve for volume, and I'll ask you to solve for density. Make sure you're good with all your units right here. Down over here, make sure you know if it's going to float or sink based on the density. Make sure you know that mass or volume alone is not a factor. Over here, make sure you know a little bit about saltwater and salinity. PPT is written as at 0/00. This means, blank number of grams in every 1,000 mLs of water. Over here, you're going to get these equations. You just need to make sure you know how to use them. Remember, you're not going to see this or this. You'll get everything to the right of the equation. Down over here, just units. This is supposed to be blank, and this is supposed to be blank. This just means parts per 1,000, and when you give me units for grams of salt, just put grams. Don't get them mixed up. Density seawater, again, make sure you know that the mass increases a lot, but the volume doesn't change very much, which changes the density. Over here, make sure you know that it has 3 main layers. Make sure you know which layer is which. Make sure you know density increases as salinity increases. Temperature goes up, density goes down, temperature goes down, density goes up. You had a sketch with that. And that basically covers everything. This last part right here, just make sure you know, like evaporation, that the poles is low, but salinity is also low because there's more water. Over here at the equator, because evaporation is high, more water is coming out of there. That means salinity is higher. And that kind of wraps up everything for this test. Just make sure you take a look at Quizlet, go over your notes, watch the videos, watch the playlist if you're still having trouble with some stuff.